Welcome all of you. Welcome to Animaths. We shall be taking up this third video. Now this is a fourth video in polynomials. So as I had told you, our fourth video will be talking about factor theorem. So in the last video, that is our third video, we have done remainder theorem. Okay, we have completed till remainder theorem in polynomials. Okay, so this is going to be our last video in the chapter polynomials from the 9th standard syllabus. Okay, so the same chapter is extended in the 10th syllabus also. So this is whatever I am teaching here today is actually from 9th syllabus. So let's see what factor theorem is all about. Now before this we had talked about remainder theorem. Okay, and when we talked about remainder theorem, we had told that when there is an expression, whatever the expression is, okay, some x square and x cube or cubic, cubic or quadratic, whatever expression it is, when it is being divided by another expression, okay, so one expression here, another expression here, this expression is being divided by this. If so, if so happens, then if the remainder after the entire division, we were trying to see if the what is the remainder. In the last video we were trying to find out the remainder when a particular expression is divided by another expression, then what is the remainder. So we were trying to find the remainder in that cases. Okay, by substituting values from the divisor we were able to get the remainder. Now remainder sometimes was coming as an expression itself, or remainder was coming as a number. So whatever it is. But then now I want to ask you something. Supposing I have here, I have let's say 45. Okay, I have the number 45 here, and here I am dividing it by a, let's say I am dividing it by a 7. Okay, so if I divide with a 7, then here, and then there's a remainder 3. So 7 is not a factor of 45 clearly. 7 isn't a factor of 45 clearly because it has a remainder here. Okay, but then if I do this, okay, and 45, and here I have divided it with, let's say this time 9. Okay, then 9 remainder is 0. So as long as the remainder is 0, I know that the divisor is actually a factor of the number inside. Okay, so 45's factor is 9, or 9 is a factor of 45. So what tells me 9 is a factor of 45? The remainder, which turned out to be 0, tells me yes, 9 is a factor of 45. So in this chapter we are also going to do the same thing. As long as the remainder of an expression comes to be 0, we know that that expression is a factor of the given expression. Okay, so that is the logic behind it. So I have told you this in terms of numbers, and when I talk about expressions sometimes it becomes little confusing. Okay, that is why I told you with numbers, so that it becomes easy for you. So if I have an expression over here and another expression is dividing it over here, okay, they say this expression is dividing this expression, and then using my remainder theorem I see that the remainder has come to be a 0, remainder is equal to 0, then I know that this expression is a factor of this. Okay, so that is what will be told. The language part of this question, this chapter, in this chapter the language part is very important. You have to read the question thoroughly and try to understand what exactly they are saying. Okay, so you'll have to understand where they are saying factor, where they are saying not a factor, or remainder is there, or remainder is same. You have to read the question thoroughly and understand. So let's take up few more questions. Our very first question is show that x minus 3 is a factor of the polynomial fx, which is x cube plus x square minus 17x plus 15. Okay, so this is the given polynomial and this is the x minus 3 is a factor or not, we have to prove. In other words, this big one goes here and this small one comes out here. This is x minus 3, will try to divide this. Now from remainder theorem we know one thing very clearly. One thing is very clear from remainder theorem, that if we substitute it, that is first thing we'll have to equate x minus 3 to a 0. Then x becomes 3. Okay, that if we substitute in fx, that is if we find f3 and f3, let's see what is the remainder. We are trying to find the remainder when this divides this. So if you are not understanding this, you can see the previous video which has talked about remainder theorem in detail. Okay, so here when I divide, I will substitute 3 everywhere, plus 3 square minus 17 into 3 plus 15. Okay, 27 plus 9 minus 51 plus 15. This is how much? This is 27 plus 9, that gives me a 36. Okay, and after 36 plus 15 minus 51, that is how much is it? 51 minus 51. Okay, so when I get 51 minus 51, this is equal to 0. So what do I see from here? From here I get to see that the remainder has turned out to be 0. Means I had told you that if the remainder is 0, the given factor, which is this, is this expression is a factor of this. Okay, therefore since remainder is equal to 0, x minus 3 is a factor clearly. So as long as we can prove that the remainder is a 0, we can say that this particular expression is a factor of the given expression. So x minus 3 is a factor of the given polynomial. Okay, so this was one of the very basic questions. Okay, after this you will see that slowly the difficulty level will go up as we proceed with the questions. So my second sum is also a very similar one. So the second question says show that x plus 5 is a factor, okay, almost similar, of the polynomial. What is the polynomial? The polynomial is fx is equal to x cube plus x square plus 3x plus 15. Okay, sorry, plus 115. This is my polynomial. So I'll have to try and see if the remainder can come to 0. What will I first substitute? X plus 5 is equal to 0, x is equal to minus 5 has to be substituted now. Okay, so x is equal to minus 5. When I substitute here, I'll write it here also. Minus 5, don't take shortcuts in this step. This I'll tell all my students. If you take shortcuts in this step, there's a large probability of going wrong. This is negative being cubed, so the minus will remain 125. This is being squared, so a plus 25, minus 15 plus 115. Okay, so here it becomes minus 100 with these two, and this becomes a plus 100. Okay, that gives me a 0. So what do I see now? This has become a 0, means when this expression divided this, the remainder came to a 0. Therefore, x plus 5 is a factor because it completely divides. Okay, because it completely divides, hence the remainder is 0, is a factor of the given polynomial. Okay, so that was very basic of factor theorem. You'll see factor theorem and remainder theorem is one step away. Remainder theorem, we find the remainder. Factor theorem, we say that the remainder is 0 and accordingly we just say that the remainder, we try and find out the remainder to be 0 and then say yes, it is a factor. So it is just one step away. Next question. Find the value of a for which, now there's a slight twist. Find the value of a for which. Now remember one thing, whenever I do sums in any of my videos, I try to pick up every type. So if you are at least copying down these questions and revising these that much will also help you a lot, because you are knowing all the different types. The numbers might change, but the sum types will remain the same. So it's actually a very, if you write them down in one place, it actually forms a very good thing, very good note, I would say, to revise before your exam. So find the value of a for which x minus a is a factor of the polynomial. Now what is the polynomial? So what is my polynomial? My polynomial is fx is equal to x to the power 5 minus, okay, a square x cube plus 2x plus a minus 3 plus 2x plus a minus 3. Okay, so this is my given polynomial. Now my job is for what value of a, that is everywhere. If this is a factor, that means I'll have to equate it to 0, x is equal to a. Okay, so if I substitute everywhere in place of x, if I put an a, then for what value of a will this entire part get converted to 0, because this is nothing but the remainder now. The remainder has to be proved to be 0. Okay, so for what value of a will I get this as 0, so that if I get the remainder as 0, I can say this is a factor. So let us see what is the value of a. So a, which is equal to a to the power 5 minus a square and a cube plus 2 into a plus a minus 3, that is a to the power 5 minus a to the power 5 plus 2a plus 3a, okay, because this with this is a 3a minus 3, but then this is a factor, they said, so we can actually equate this to 0. We can equate it to 0 because we know this remainder has to be 0 because this is a factor. We assume that this is a factor. Only thing we are going to do now is find the value of a. So this is 3a is equal to 3, a is equal to 1. Okay. So a is equal to 1. So we have found the value of a for which this given expression can become a factor of this. Means, in other words, if I put 1 here, x minus 1 will be the factor, and here also I'll have to put 1. Okay, so this expression is going to get converted to x to the power 5 minus x cube plus 2x minus 2, because if I put 1 here, 1 minus 3, that gives me a minus 2. So for the value of a as 1, this is a factor of this. So our next sum. Now this, as you are seeing, slightly the complication is increasing. For what value of k? For what value of k is 2x to the power 4 plus 3x cube plus 2kx square plus 3x plus 6. Exactly divisible by x plus 2. Exactly divisible by x plus 2. So this is the part, this is the expression which is dividing this. Okay, but then for what value of k? Now see, if you note this question, they have written the question in a slightly different manner, and here when they write it, they don't talk about factor. Now people who are used to the word factor might find it little tough. Okay, what they're trying to say is the same thing. As I said, language is very important in this question. So x plus 2 has to be a factor of this, because they are saying this is exactly divisible by this. When a number is exactly divisible by the other number becomes a factor of the first number. So this, in other words, they are asking for what value of k is this a factor of this. So back to the same question. So here I shall be substituting x is equal to minus 2, right? X plus 2 is equal to 0. X is equal to minus 2 is what I'll have to substitute. So here if I write f minus 2, because I'm substituting anyways. So everywhere where I have x, I will substitute minus 2. So here I will substitute minus 2 to the power 4 plus 3 minus 2 cube plus 2 k minus 2 square plus 3 minus 2 plus 6. Yeah. So I have substituted and I put brackets. Note, without bracket, don't put the cube. Put the bracket outside the cube. If you don't use this bracket and you just put the cube here, you will be cubing only the 2 and not the minus sign. So you must put the bracket whenever you substitute. Okay, even if it is positive, get into the habit of putting brackets. So here it is 4 into 4, 16, 16 into 2, and this anyways becomes positive because of the even power, 32. Okay, so I have 32 minus, this is 8 and into 3, 24 plus this is 4 into 2, 8, 8k minus 6 plus 6. Okay, then I can cancel this out, and this, since they have told this is a factor of this, we can equate it to 0. Okay, so we can equate it to 0. Now this comes to how much? This is a 32 minus 12 is 32 minus 12 is an 8. 8 plus 8k is equal to 0. Okay, so 8k is equal to minus 8, k is equal to minus 1. So the value of k for which this expression is a factor of this is a minus 1. Okay, so if you put a minus 1 over here, this one will be divisible by that one, that is remainder will be 0. Okay, next question. Okay, as I said, the difficulty level will go up. This is slightly more difficult. Okay, these are the sums. This one, or the now the one that I'm going to take up, are the questions that come for about 4 marks generally. This will be for about 3 marks, and the next one that I'm going to do will be about for 4 marks. The question says, without actual division, without actual division, prove that without actual division, prove that 2x to the power 4 minus 6x cube plus 3x square plus 3x minus 2, okay, is exactly divisible by x square minus 3x plus 2, okay, is exactly divisible by x square minus 3x plus 2. So, without actual division, prove it. So, what do we do? Here again they are saying, so they are they are stopping you from doing actual division. What do they mean by this? When they say actual division, they mean the long division method, which they are telling you not to do. Okay, this expression is exactly divisible, means this one is a factor of this. Now this is what we have been doing, last 4 sums we are doing the same thing. The only difference is now this factor is no longer a binomial or no longer such a simple expression that we had come across. Now this expression in itself is a little complicated. This is a quadratic equation. Okay, so what we have to do is, earlier also we had equated to 0, right? X plus 5 we equated to 0 in the previous question. So here we are going to equate this to 0 again. And now this becomes a quadratic, from a quadratic expression it has become a quadratic equation. Now in this quadratic equation we have x square. Now we are going to split x square. We will use splitting the middle term method. Okay, that is minus 2x and a minus x, okay, and that is so x minus 2 and x minus 1 is a 0. Okay, so if it is x minus 2 and x minus 1 is a product of x minus 2 and x minus 1 is a 0. Now here, now starts the confusion. If I have x minus 2 and x minus 1, it's like, you know, I was given, it's like this, I was given, let's say I was given 72, okay, and I said, okay, 12 is a factor of this, you know that 12 is a factor of this, okay. Now if I split 12 into 6 and 2, okay, or 3 and 4, 3 and 4 or 6 and 2, everything is going to divide 72. So if this is a factor, remember its factors, if you split them into further factors, that also divides this number. So here I had something which I thought is a factor, but now I have split the factor into 2 more parts. Okay, I basically factorized this. So this one is now split into 2 more parts. Okay, so each one in itself is a factor. So what I can do is treat them. So x minus 2 and x minus 1 are factors. Okay, so what I can do now? I can substitute the values. Okay, I can substitute the values as I was doing for the previous sums and get and prove that it is divisible. So first I will substitute x is equal to x minus 2. This one I am going to use as a factor first. Okay, so what do I do? X minus 2 is equal to 0. So x is equal to 2. So first I am going to substitute f2. Okay, my equation is 2x to the power 4 2x to the power 4. So 2 to the power 4. Okay, minus 6 2 cube. You can see it from my from the previous question, from the question that I had written on the board, plus 3 2 square, plus 3 2 square and plus 3 into 2 and minus 2. Okay, now this is 2 to the power 5, which is a 32, minus 6 into 8, that's the 48. Okay, then plus this is 12 plus 6 minus 2, that comes to how much? That comes to, this is 32 plus 12, that is a 44. 44 plus 6, that is a 50. 50 minus 50, that has come to a 0. So I added this two and I added these two. Yes, and I got 50 minus 50, which is equal to 0. If 50 minus 50 is equal to 0, I can definitely say that x minus 2 is a factor. Okay, so x minus 2 is a factor. My other factor is this. So I am going to substitute x is equal to 1 now. Now how do I substitute x is equal to 1? So f1 is equal to 2 into 1 to the power 4 minus 6 1 cube plus 3 1 square plus 3 into 1 minus 2. Okay, that gives me 2, and then that gives me 2 minus 6 plus 3 minus 2. Okay, which is equal to, this is equal to now 2 minus 6 plus 6 minus 2. This is equal to a 0. Okay, so what have I proved? I have proved that x minus 1 is also a factor 2. Okay, so if I have a big expression which when split into two different smaller expressions and both the factors of that expression, that is this one and this one, is a factor, that means the big expression, that is x square minus 3x plus 2 is a factor, because factors of this was a factor. Therefore, this itself is a factor. So this was factor theorem. So this is it in polynomials. So this is it in polynomials. This is factor theorem that I just explained right now, and with this we actually complete polynomials of 9th standard. Okay, so I hope you have followed the chapter, and please do the similar sums from the exercises. You'll see that in the exercises very similar questions will be given. Okay, so if you have liked the video, do not forget to like, share and subscribe. In the description box, I shall be providing all the links of all the different parts of, all the 4 parts of polynomials you shall be finding in the description box. Factorization, which comes after polynomials, will be found in separate videos. I shall be providing the link of those two. Okay then, bye all of you.